Hello and welcome everybody. Welcome to Apache Ignite Summit 2023. I'm very glad to be here and I'm hoping that you guys have had a good morning so far or a good day so far attending some of the sessions that you did earlier. And I'm looking forward to speaking to you today. I appreciate the opportunity. What I'm going to do today is I'm going to talk a little bit about the power of Apache Ignite and where it's heading and where it can go in the context of recent trends that we are seeing in data and data management. But before we go there, let's start with a small lesson in history. Let's go back down memory lane and look at who these people are. Let me give you a small hint. 1983, 1991, 1994, 2007, 2014. These are all the years in which these people did something amazing, something wonderful, in some cases groundbreaking. Here's another clue for you guys. Do any of these logos sound familiar? Do they look familiar? Hopefully the last one on the right at the bottom is very familiar to all of you. Richard Stallman, he was, I could arguably say, the pioneer in the whole notion of open source based software. In 1983, he developed and made available the entire source code of the GNU processor. Linus Torvalds, in the year 1991, came up with the idea of open source based operating system, called it Linux, and made it available to the community. In 1994, the father of Java, James Gosling, made the entire Java platform, the Java development platform, the JDK, the JRE, all of it available to the open source community. Nikita Ivanov and Dmitry Setrakin, in the year 2007, founded a company called GridGain Systems. And in the year 2014, they donated the entire code base of GridGain to the Apache Software Foundation, and that became what is now known as the Apache Ignite project in the ASF. With that little lesson in history behind us, let's take a look at what's happening in the world of data lately and what it means for us. We are going through a very interesting phase when it comes to data and data management. There is a perfect storm of technological changes, and drivers that are leading to a rising tide that is lifting all boats in the world of data together. Artificial intelligence. All things that we expect to be automated and smart today would not be so without the availability of all relevant data and our ability to process it. So for artificial intelligence to really work, for things to be smart and automated, there is a need for data to be made available to those systems that process that information in real time. Information and intelligence can only be so much intelligent as the data that feeds into it. Everyone says AI is changing the world in front of our very eyes. The truth, though, is that AI has been around for a long time. What has really changed is our ability to give the right kind of information to these AI models and at the right time. And this has happened partially because of cheap storage, because of high network speeds, because of network capacity, and because of processing capacity. 5G played a role in making data and information available over the network at high speeds. A large amount of information can now move across the networks with very low latency. Technology trends like IoT took off because not only was it possible to process large amounts of data and large amounts of events or move large amounts of data and events over the network reliably, but in some ways, the demand for digitally managing your physical assets, the demand for IoT helped fuel the need for technologies like 5G and technologies like AI. And then finally, there's social media. As our data grew, especially with social media, the need for instant gratification and the need to share and absorb information in real time became the norm. And as our data grew, the ability to process the data, the need around leveraging all this data also evolved. Today, you can extract so much information out of all of your social media feeds, everything from customer behavior, their preferences, what people like, what they don't like, where are they at this point of time, what are they doing at this point of time, how do you take advantage of that information, how do you leverage that information to provide personalized services is all possible because of all of this information that is being made available and our ability to process all of this information. Now let's take a look at what is happening on the business side around this data that is being made available. But again, these four trends, if you look at these four trends have sort of fed into each other. AI drove IoT, social media drove the amount of data that is being generated. 5G drove the ability to process large amounts of data. Compute capacity and GPU processing drove our ability to process information at high speeds, which in turn made AI more legitimate, more reliable, and more applicable to what we are doing today. So all of these technology trends sort of fed into each other, leading to a perfect storm of information that we have today. So what business trends are coming up that are leading further to the demand of data and leading for us to process information faster and so on? Data hubs. If you look at low latency digital integration hubs or data hubs, they have given enterprises the ability to aggregate large amounts of data from multiple sources in real time. And not only just aggregate data from multiple sources, but to be able to assimilate that data, embellish that data, curate that data, manipulate that data, and make it available to consuming applications. All required to be done at low latency in near real time. Because if you can't do this in real time, this data hub is no different than a data warehouse or an operational data store that has been existing for many years. BNP Paribas, in fact, talked about this. They talked about using Ignite as a data hub, I think at the Ignite Summit 2 years ago. They have over 100 different sources of information that are feeding into this data hub in real time, aggregating about 20, 25 different terabytes of data, manipulating that data, embellishing that data, curating that data, and making that data available to asset managers globally. Everybody from equity traders to bond traders to commodity asset managers to currency traders across the world, across their different locations and financial centers in the world are getting data from that one data hub that they create and make available in real time. With data available in real time and with our ability to process it, enterprises have started to use AI and ML techniques to make smart decisions. Our ability to process streaming data, ability to process large amounts of streaming data, in fact, from all these different sources, from social media, from other technologies, other technology providers, other data providers, and making it available in a way that you can actually extract intelligence out of the stream, you can process it, is leading to a lot of these decisions that are being made easily as well. Prevention of fraud as opposed to recovery from fraud has become prevalent. There is really no credit card company today that actually is focused on how to recover from a fraudulent activity. They are more focused on how do I detect and prevent fraud in real time before fraud even happens, because it's a lot more economical to prevent fraud than to go after a fraudulent activity that has happened, chase after it, try to recover from it, and extract any kind of value out of it. The end user experience, the cost of doing this, both are not something that makes any sense. So there's a lot of investment, a lot of demand for real-time processing. In a lot of ways, that's also leading in general to a lot of operational analytics. Fraud detection, you could argue, is sort of one way of looking at operational analytics, but the ability to analyze information and make decisions within the context of a transaction is starting to emerge. It's coming up as a mechanism for businesses to react to and respond to events in real time. These business use cases, data hubs, smart decisioning, stream processing, fraud detection, operational analytics, these business use cases are also highlighting some of the challenges that exist with data processing today. As the amount of data is increasing, and as the velocity of change of this data is increasing, it has started to put a strain on these various enterprise systems that process data. Processing and aggregating large amounts of data within silos has become a problem. So for an application that's a transactional system that is working with a set of data responsible or required for that application to work successfully, as the number of transactions increase, as the number of concurrent transactions come into play, as the data volumes increase, these data silos are getting strained. Every time data moves from one silo to the other in its life cycle, every time data hops over boundaries of applications, of systems, it introduces latency. We've also started to see problems with scale. As workloads have increased, as transaction volumes have increased, as concurrent transactions have increased, the scale that is required to be able to manage all this information has increased exponentially as well. And this is leading to issues around how these technology trends can be supported with that scale. And of course, finally, crunching of such massive amounts of data in a time that's reasonable and useful. It's not just that you have to crunch a large amount of data, you have to crunch massive numbers, run complex models. None of this is important, or none of this is useful or of any value to businesses if it cannot be done in a reasonable amount of time. If it cannot be done in the context of a transaction, if it cannot be done in the amount of time, in the ephemeral time in which somebody has to make a decision, a trader has to decide if they should execute that next trade or not, if they should be able to make a financial decision or not. And if these types of computes cannot happen in that very small time window, the ability to compute this large amounts of data is of not much value. So that's kind of what's happening today. But what is happening furthermore is that we have solutions to these problems. We know that we can solve problems with data silos. We have caching technologies out there. We know that there's ability to limit the movement of data or hasten the movement of data over the network with high-speed networks and gigabit and 10 gigabit bandwidth capacities and so on. And we know we can scale. Hyperscalers are available to be able to scale data across cloud environments and across infrastructure and so on. So there are solutions available to solve each one of these problems individually. What's not quite easily available is solutions to solve multiple of these problems, multi-dimensional problems simultaneously. Now, why do you run into these multidimensional problems? And what I mean by multidimensional problems, what I mean here is that the need to be able to not only expedite or accelerate processing of data within a silo, but also do it with limiting the latency of data movement between silos while doing it at massive scales and while doing it at high performance, running complex processing, complex simulations, complex AI models, doing all of these things together. Because what's happening is without doing all of these things together, you still, at the end of the day, do not get the value out of your data. But why are these multidimensional problems coming up now? What's happening that's leading to these problems? Let's take a look. Let me start off with explaining what's happening with data today. The scope of data has changed. What is relevant to an application, what is relevant to an enterprise has changed. Earlier on, the context of data was all the information needed to run a given application. It was a self-contained unit with its data and processing logic inside monoliths or tiered applications. So all of the data, all of the processing that was needed to be able to execute a business use case was self-contained. Then what happened? Enterprises got smarter. They realized that they cannot just work within application silos. They should not work within application silos. And why is that? They realize that they can get a lot of valuable information on their customers, their products, their business operations, if they just looked across data or looked at data across these applications within their enterprise IT. The scope of data extended to all applications within their enterprise IT, to all systems within the firewalls. And that's what led to data being manipulated, data being ETL'd, data moving into data warehouses, to operational data stores, to master data management platforms, to data lakes. All of these technologies came about because enterprises realized that they want to be able to move their data across applications into a central location so that they can analyze it, they can view it thoroughly, they can view it holistically, and they can analyze it. However, this whole process of moving data from applications, manipulating it, transforming it, doing that ETL process, storing it into a central repository, making it available for processing, was all done in a matter of hours and sometimes days, overnight, whatever, right? All of this took time, which again, what that meant is, given the world we live in today, this wasn't enough. This wasn't fast enough. This wasn't enough for us to be able to make anything very useful out of information. It was all yesterday's data. It wasn't what's happening today. It wasn't what is relevant to us today. Today's world is very different. In fact, the world has been very different for some time now. If you look at the global economy, the world shrank and became more accessible. The connectivity between regions across the world increased. And with it, the dependency between these regions as well. The same happened to data. Just like if you kind of go back to what was happening in the supply chain world, when COVID happened and the world was shut down, everything stopped. Factories in China stopped. Shipping of goods and services, not services, but goods really, raw material and finished goods from Asia to Europe and North America stopped. Why? Because ports were down, factories were down, workers could not go to the office. They could not go to their factories and their plants to get work done. So that impact, we are still dealing with it, by the way, today. Even today, it's not easy to get exercise equipment. There's a long wait time to get cars. Furniture is not available easily. If you have to go, uh, upgrade your living room, it's going to take you time to be able to get what you want, or your choices are very limited. And all of that is happening because of the impact that happened with an outage somewhere in the world to your global supply chain. And that's sort of what's happening with data as well. Data has become like your global supply chain. Data has become something that is now global. For an enterprise, it gets impacted by data and by events that are happening somewhere else in the world. We all agree that an economic policy change by a government or a political instability or even weather patterns or natural disasters on the other side of the world impact us in some way or the other. And we have to understand and process this data that is generated and managed outside the firewalls of the enterprise. It is important. And that's what has happened to enterprises today. Their ecosystem, the relevance of data or the scope of data that is relevant to these enterprises has gone beyond their four walls, has gone beyond their applications to beyond the four walls of their firewalls to partners and open systems and third-party data and the social media feeds and political events and news that's coming out and government decisions around their economic policies. All of those things have become relevant. All of these things impact what happens to an enterprise. All of these things impact what decisions these enterprises can make. And that is where what has happened to data. The scope of data today has become global. And because of this, there has been introduced a level of latency in your data ecosystem. So if you look at your data ecosystem, enterprises today have to make decisions, real-time decisions, based on geopolitical events, based on financial news, based on changing weather conditions on the other side of the globe. A financial asset manager, a trader, a portfolio manager has to react to any of these events in real time and change their trading strategy. But as data moves through this ecosystem, and this ecosystem, again, data that's coming from your partners, coming from data that you have purchased or procured from a third party, all the way to your transactional systems, to your event stream, to your stream processing platforms, to your data hubs, to your dashboarding, reporting, to your operational data stores, to your decision engines, to your reporting and dashboarding, to where you can do analysis, where you can make smart decisions. All of that, as your data moves through all of these different systems, every time it crosses a silo, every time it crosses a boundary, it introduces a level of latency. A Gartner analyst once said about data once, there is only one opportunity for data to be real time. And as soon as this data lands anywhere before it's processed, it's no longer real time. Think about it. If your data lands anywhere before it's processed, it is no longer real time. There is only one opportunity for data to be real time. For that one fleeting moment is where your data is real time. Anything after that, anytime after that, forever, the life of the data, it is never ever going to again be real time. So can we really eliminate this latency? Probably not. However, at least not just yet, I should say. However, it can be minimized. We can minimize this latency between systems by minimizing the number of hops this data has to make across its ecosystem in its entire life cycle. So if you can limit the number of systems that data has to cross, limit the number of those silos, the boundaries that data has to cross, the lesser latency we will have in that data ecosystem. Gartner calls technologies that helps minimize these hops as unified real-time data platforms. These unified real-time data platforms have the ability not only to stream data or process event streams, but also to process, analyze, manage, and store this data. These platforms process event streams as they come in, they behave as data hubs, they execute decision models on the data, they then persist that data and make the data available appropriately. So how does Ignite feature into all of this? Well, hopefully, when I talked about stream data ingestion, event stream processing, data hubs, transactional systems, and accelerating transactional systems in isolation, operational data stores, and decision engines, you think of Apache Ignite. Why? Because Ignite does these things for you. Ignite behaves as a data hub. Ignite is a stream processing platform. Ignite is a compute grid. Ignite is a cache. But you know what? There's a lot more to Ignite than that. It can actually address all of these use cases simultaneously. It is that unified real-time platform that can help you minimize latency across your data ecosystem and simplify your data architecture. If you go back to this picture now, this is what Ignite can do. Everything that you see there in red, that can be done by Ignite. And suddenly, your data platform looks a lot simpler than what looked in this picture. It has a lot fewer moving parts. It has a lot fewer boundaries that data have to cross over to. It reduces the latency. And that is the power of Ignite. Now let's look at how can we make this real? How do we make this happen? How do I make sure that we can actually leverage Ignite the way it is supposed to be leveraged, the way it can be leveraged? For that, let's first actually look at the key influencers or stakeholders in the free and open source software economy, FOSS economy. The way I see this, there are three key components in your free and open source software economy. I call them the three C's of the FOSS ecosystem. First is the corporate sponsorship. In the case of Ignite, you have GridGain. GridGain is the company that wrote the code originally, donated it to the Apache Open Source Foundation in 2014. And GridGain's developers have been constantly adding to that application code, including the upcoming 3.0 release. Next, there is the consumer. For every product to be successful, there has to be enough number of consumers. And these consumers are the ones that create a demand. These interested consumers are the ones that power the growth of the platform and fuel the direction and influence the direction that the platform takes. Because they're the ones who leverage the platform, who use it. And without the users, the platform is nothing. It means nothing, right? So they are the ones that have the power to be able to influence what happens with Apache Ignite, what direction it takes, where it goes. And finally, there's the community. These are the custodians of Apache Ignite. We have a very healthy and strong community. Apache Ignite has about 40 PMC members. It has about 100 code committers and people who are contributing to code from all over the world. And we have millions of downloads. But for Ignite to reach its true potential, for Ignite to be able to be that platform, to be that unified real-time platform, the consumers and the community, including the GridGain developers, have to play a role, have to play a bigger role. And what exactly is it that we can do? Let's see. Everything, as we start to use the platform, as we use Apache Ignite, every little thing from discovering a bug to reporting it, to be able to contribute fixes and enhancements to the application code for bugs that you've discovered or ideas that you came up with saying, you know what, I could really use Ignite this way. Let me add a little bit of an enhancement to the platform. Let me give it back to the community. It's a very symbiotic relationship. You take some from it, you give some from it, only then it can be healthy and strong. Sharing your design and implementation ideas and solutions of your use cases with the rest of the community. How do you do that? We invite people every year to the Apache Summit, Apache Ignite Summit. Being available, being willing to talk about how you're using Ignite, what amazing thing you did with it, how were you able to solve your problem with Ignite, making that that idea, that architecture, not necessarily something that's your IP, but use cases, how you went about solutioning your problem statement around Ignite. All of those things are very useful and very important. And finally, being able to participate in meetups and conferences, not just necessarily the Ignite Summit, but even in other conferences. If you go to an AI conference, if you go to the AWS conference or any other event, any other relevant event around data and how you're leveraging data, any other business vertical focused event, so anything around risk analysis, financial analysis, real-time supply chain management, being able to make real-time decisions, being able to run simulations for healthcare, for logistics, transportation, whatever it is. Anytime you're solving a problem, please talk about it. Please share how you solved that problem, how you're able to creatively leverage Ignite to address the problem and to solve it with others in the community. At the end of the day, an engaged community is a stronger community. And we at GridGain are with you, and we look forward to your engagement. We are here to support you, and we are here to work with you to make the Ignite community stronger. I would like to end my session with thanking our core committee of volunteers who've been responsible for hosting this event. The summit committee has 4 members: Suman Das, Maxim Musafirov, Stephen Darlington, and Ian Ruffle. And I thank them for going through a lot of our submissions and our presentations, reviewing everything, making sure it's done correctly, making sure it follows the guidelines of the committee and so on. And then all of the numerous people who've been working behind the scenes, everybody from people who've been coordinating the timing and the event, making sure that the technology is working successfully, making sure these presentations are live and running successfully, coordinating questions and answers, all of those things. Everybody who's put in numerous hours, volunteer hours of their time behind this event, I sincerely thank them as well. And I thank all of you for listening. I know we are running short on time, so we may not have time for questions, but I would like to thank you for listening to me today. And you have my information here. You can reach me via email, on LinkedIn or Twitter. I look forward to hearing back from you. If you have any questions, feel free to please reach out to me, and I'll make sure I respond to you right away or as soon as I can. Thank you again. Thank you for listening to me. I hope you enjoy the rest of your conference. Have a wonderful rest of your day. Thank you.